Dr. Robert Pavia. Robert is an affiliate professor with the UW School of Marine and Environmental Affairs. Dr. Pavia has also had an extensive career working for NOAA as a physical scientist, 31 years. Yeah. His major research interest is disaster science, or the science of disasters, right? So he is really focused on scientists and the public and mitigating the human and ecological impacts of human-caused and natural disasters. And so today, Robert is going to present on disaster science, response, research, and instruction by exploring some examples that illustrate all three of those elements, and probably talking about how librarians and library resources can play a role. So please welcome Dr. Robert Pavia.
Thank you. I get to do something I love to do today, which is talk about disasters. And I'm going to talk about it. Matt mentioned I'm going to sort of tell a story in 3 parts, and hopefully you'll see how research and information sort of travels down the path from an event to the classroom. And I encourage and enjoy questions. You can stop me while I'm talking, or we'll have some time for questions at the end. And I want to talk about the context of science and informing decision-making. And I start off with this slide because this is a painting of an oil spill, the new Carissa spill off the coast of Oregon in 2000. And if you look at it long enough at the base of the flames, you can see the ship. This was the response measure for this oil spill was to burn the oil in place, which created a lot of fire. And those of you from the Northwest or Oregon, any of you remember this still? Yeah, okay. So I mention this because science takes place not in a vacuum, but in the context of a social, political, economic context. And it affects us in a lot of different ways. And if we think about decision making, which is where I sort of fit in this equation, we have to think about the science in that context. And that context includes art and music and literature and everything else, and food, everything else that we do in our society. And I look at disasters as kind of a microcosm of decision making for, in my case, marine environmental problems. You face all the scientific, social, economic, and political issues. You have uncertainty and conflict, and you have to deal with it in a very short period of time. So you sort of have this whole crucible of experimentation for how society deals with these problems. And that's why it's of interest to me. So these are 3 examples of disasters. The Casa Concordia, which is a cruise ship that grounded in Italy. The Culloch, which is a drilling platform that was actually in Seattle, being fitted out for drilling in the Arctic, in the Chukchi Sea, went aground at the end of the drilling season. And the Deepwater Horizon, which is the one that I'll focus on as the example for today. So why oil spills? I'll let you read some of these quotes, but it turns out oil is pretty important in our society. We go to war over oil. It has great economic impacts. How many people noticed the price of gas over the last week? Which direction did it go? Every time you drive by a gas station, what do? Yeah, you look at what the price of oil is doing. You don't do that for any other commodity that you deal with. You don't look at that for the water that comes into your house, even though you buy it the same way by the gallon, right? So oil spills are very interesting in this context, politically, economically, and environmentally. And so I think they provide a good illustration. So the 3 examples I'm going to talk about today, I mentioned that they're all connected to the Deepwater Horizon in some way, although the instruction is more general. I'm going to talk about data collection and analysis during an event. And I feel like I'm a little bit of a bridge because you heard from Jan Newton earlier, so we're in the ocean, right? You already got your feet wet. And this afternoon, you're going to have a speaker talking about disaster informatics. So I'm working the two sides of that equation. The second thing I'm going to talk about is a multidisciplinary research project that was a collaboration of researchers on campus here at UW. And the third piece I'm going to talk about is a class that I teach in the spring, an undergraduate class I teach in the spring, whose title is Disaster Science. And hopefully those pieces will connect for you and some of the things that you're interested in. So Matt introduced me. I'll give you a little bit more background. And I do that, I mentioned that we respond to oil spills in a social context. I exist in a social context. This is part of my social context. You'll see my wife there and what she's standing in front of. Where did we meet? Oh, that is close. That is really close. But no, we met in a geography statistics class. But we have a very strong interest in maps. That's our bathroom. This is my daughter, who graduated here from UW as an undergraduate, and she also graduated from the Ivy School with a degree in public administration. And until the end of this month, she is employed. She just quit her job, however, and she's going back to school in economics. And my son, who just graduated through no fault of my own with a degree in environmental science, and he is starting graduate school in the fall also. And you heard a little bit about me. I spent a long time working for NOAA, National Oceanic and Atmospheric Administration. I worked mostly in oil and chemical spill response, mostly technological disasters, a few natural disaster kinds of issues. And then I also, towards the end of my career there, worked on marine protected area management. And then made this transition to UW and teaching a few classes. Okay, so the disasters. We'll start off with the Deepwater Horizon. How many people remember the Deepwater Horizon oil spill? How many people thought the Deepwater Horizon spill was a disaster? Okay, we're off to a good start. So I have a few more questions for you. So think in your mind one word that you associated with the first news you heard about the event. Anyone want to call some out for me? Pollution.
Loss of life.
Loss of life.
Gulf.
Gulf, the place. Environmental impact. Halliburton? Yeah, okay, good. Guilt. Did you get some? Okay, so, did I see a hand? Horror.
Yeah.
So I think the difference in the words in part comes from when the event may have entered your consciousness too. Because the very early reports about the event were about the human tragedy, really, and less about the pollution. It was really about 2 days later when it became more of a pollution event. And I have to admit too, when I first heard about this, of course these kinds of things happen and little things fire in my brain. And I looked at it and I said, human tragedy, not much of a pollution incident.
Because that's what they said.
Yeah, well, and that's what they believed at the time. You may not. I would say that in the first day or two, the truth was being told. We're going to get into that, your skepticism, here in a minute. So, next question, what failed? Cap? The well cap? Inspection? People, I would say, if this was my class, I would say, you get an A for that answer. All those answers are correct, but it was really a failure of the human system associated with this rather than a technological disaster. Blame. Okay, so blame. So we heard Halliburton. Anyone else? I'm sorry. Capitalism. Social context. Oh, okay. That was more at the president's footsteps. This was in federal water. I would say. Bobby Jingle failed later.
Increased global energy demand.
Global energy demand, thank you, all of us.
Us.
We drive cars. I heard another one over here. Regulators, yes, very much a regulatory failure. Did I hear another one? Okay. Okay, so today, you think the impacts were more or less than what you thought during the event? More? Less? A few people, at least, yeah, a couple people fessing up to that. Okay. Okay, so has your opinion changed? And if it did, what was the influence? So you can think about that one a little bit. All right, so disasters are complicated things from a social and political context. And I also look at them in this context. Is there a place to learn? And this is the device that was the proximate cause of the disaster. This is the blowout preventer. This is the last line of defense for all the other human failures and technological failures that took place. And this is a picture of a robotic arm trying to turn the valve to close it. Didn't work. We learned a lot from this. The question is have we learned enough, especially in the context of where and how we're continuing to explore for oil. So I want to talk about a particular issue. What do we know and when did we know it? Where was the hidden oil associated with this spill? And so this is a spill, a little bit unusual. It was a blowout at the bottom of the ocean. It was about 5,000 feet deep. And so we had, instead of a spill that we normally have, which happens at the surface of the ocean, like when a ship goes aground, you spill at the water surface. This one we spilled below the surface. The oil was buoyant. Most of it came to the water surface, and that's what we mostly talked about. That was where the response was for the most part. But we had this subsurface oil. And right at the beginning, there was this debate about whether or not that oil was there. And so you can read some of the quotes. And I believe that these quotes point in part to your skepticism about how we were being informed about the spill and whether or not the truth was being told. So we have the head of BP. There aren't any plumes. Now he, as an individual, maybe at that moment didn't know there were, but there were lots of people in his organization that knew there were because we had lots of research that told us we would have plumes. So it was not a surprise, should not have been a surprise to anyone who had studied the problem. Then we had the person who was in charge for the government. I've said time and again that nothing good happens when oil is on the water, and I think that's a good characteristic of any oil spill disaster that we have. But then we have scientists starting to come into play, and the interface between science and the information flow to the public, which I think is something that all of you are very interested in. And also interested, obviously, in the flow of information to and from researchers. So researchers briefed reporters on an underwater oil plume 15 miles wide, 3 miles long, and 600 feet thick. Now, unfortunately, this screen slightly cuts off the bottom line here, which is that if you do the calculation on the cubic meters of water/oil in that, it's 24,000 times the amount of oil that was spilled based on the best estimates during the spill. So there was there are a number of failures there. I think there may have been some failures on the part of the researchers extrapolating the information they got very early on, and they're concerned about what the consequences of this spill might be. There was probably a failure in communication because researchers don't usually report on a dock when they come back from a cruise about the results from their finding. But they're being pressured to do that. And then we have, even though this is the New York Times reporting on this, we probably have people involved in conveying information who are not used to conveying information in the context of a disaster, which I think is going to be part of the discussion this afternoon. And then we have quotes like this in a reputable newspaper, the New York Times, it's an infusion of oil and gas unlike anything else that has ever been seen anywhere in human history. Wow. Now there are some people that might debate that, but that's the quote, that's the context of the quote in which this exists. So I'm going to have to accelerate here a little bit, but so now we'll get into the science a little bit. So to orient you, we have Louisiana, Mississippi River Delta at the top. You can see the wellhead. Your right, you see basically where the surface oil was, and to the left, you see where subsurface oil was. Now, it was relatively easy to see the oil on the surface. It was relatively hard to see the subsurface oil. And what happened is, if you look at this illustration, actually done by one of the medical illustrators here at UW, here's the well, the oil going to the surface, the majority of it, but some of the really small droplets got trapped in this water layer, which is actually cold, oxygen-rich water from the Arctic, and basically stayed in that area. So let's look at how we figured out where it was, because this is the science problem we talked about. So here's point A, point B, and point C. You can see we're about 1,000 meters, 1,300 meters below the water surface. So we want to find that oil and decide, try and understand what's the consequence of that oil there. So here's a little bit of our problem. Is the oil's at 1,200 meters. If you want to send a sampler down there, it's going to take you about an hour to get it down and about an hour to get it back. And you're going to have a sample at one location. One location about the size of me in an ocean of thousands of square miles. So it makes it a very difficult problem. So how can we measure this? Well, we need a whole bunch of different measurements, a whole bunch of different instruments to measure this, and they all measure slightly different things in slightly different ways. So it makes the problem of understanding where the oil is and how it's behaving difficult to measure, evaluate, describe, and communicate. So while it would be easy for me to point out and fault the researchers whose quote I showed you at the beginning, I shouldn't do that because it's a complicated problem. And there's a lot of uncertainty associated with that problem, and that characterizes disasters and lots of other things that we deal with. We have uncertainty, and we have conflict associated with what to do with the information. So we had to use lots of different kinds of instruments to measure different things, properties of the ocean, properties of the oil. And these are the kinds of answers that we got. So two of the important parameters that we wound up looking to measure was hydrocarbons, the oil itself, and oxygen. Any guesses about why we care about oxygen in this equation?
Suffocation of organisms.
Suffocation of organisms. That's good. Why might we have lower oxygen levels? Because the oil is lunch for somebody. For lots of somebodies, it turns out, and they require oxygen. So remember I showed you ABC moving away from the well. So if we look here on A, the red line is dissolved oxygen. And you can actually see that the oxygen at the upper levels goes down. That's what happens in the Gulf of Mexico in that area. In fact, it goes to zero in some cases. There's natural hypoxia in the ocean there sometimes. And then as you go deeper, the line moves that way, which means there's more oxygen. Here's the scale, the right scale for that. The other line, you see the black line, squiggly line, is the oil. It's a measurement of the oil. And you can see near the surface, you don't see the very surface where the floating oil is because it's at a scale we're not measuring with these instruments. But as you go deeper, you can see right around 1,200 feet, we get this big bulge in the oil near the well. That's a good thing. Well within the sensitive range of the instrument. In the middle line, anyone want to guess what's different there? What's the red line doing? Spiking, a little hard to tell, I'm guessing, but we got depression in oxygen now. So here we have an increase in oil, this nice zip, and here we have a decrease in oxygen. So what this is telling us, we have both oil present, somebody's eating the oil. When they're eating the oil, they're breathing, they're consuming oxygen, it's depressing the oxygen level. And really, one of the key concerns during the event was whether or not oxygen would be depressed to the level where organisms would not be able to respire. And there's a level, there's a threshold for that. It got very close to that, but except for one measurement in the thousands, it never got below it. And now we're furthest away on station C, and what do we see for hydrocarbons? Nada. And then left, but what about the oxygen? Still depressed. So we're still seeing the signal here. If you care about the effects of this, you're worried about that oxygen too. So to get to that answer took about 3 months and about 10,000 samples in order to begin to understand that. And eventually, what we were able to do is map. So now at the far upper right corner, you have the well. And then you have distances from the well, 100 kilometers, 200 kilometers. That's a long way from the well. And you see the areas that were sampled. So these are transects, occupied multiple times. And then you see how much oil is present. So red was the highest level. This was the highest reading recorded over the period of sampling. And you basically could see that then the way the plume was moving could be mapped. And that was how we got to the question of where is it, how much is it, and where is it going? And it turns out it followed the bathymetry pretty well. The red squiggly line there is 1,000 meters. It's shallower to the upper part of the screen. It did not go up into that area. There was a big area of debate. There was contention that the oil would surface and oil beaches. It took a lot of work to be able to figure out that that wasn't going to happen. This required not just the sampling in the field to do the work, but an understanding of the physical oceanography of the area, the biological communities of the area, and that required knowing the research that had been going on in the area over decades in order to set the context against which you could compare these data. So for example, the fact that it was in that layer of water, where was that layer of water? That relied on a long series of data that had been collected. And I think Jan talked about IUS earlier. So that's an application of IUS kind of data that was used to characterize that water layer, which turned out to be oxygen rich, where the oil wound up. Knowing where that water layer was helped us understand where to look for the oil. So the context, that's a little bit of context for that. That's sort of the Deepwater Horizon piece. But I want to talk about the science piece and the fact that there were multiple people doing research. And I have some quotes here that quote one particular scientist. It's not my intent to point a finger at that researcher. These quotes just happen to help illustrate my case. There are lots of different viewpoints, but the way the viewpoints got communicated depended on who was communicating them and how they were communicating them and how willing they were to communicate them. So the people within the response were not talking directly to people outside the response. They were providing information for a particular decision-making process. There were lots of researchers doing work not connected to the response that were talking to the press in some cases, but some of them were not talking to the press. They were publishing the results in the typical way, which would be in a journal. And how long would that take? Well, in this case, it didn't take years. And I'm just going to let you read these quotes here. I'm not going to go into any more about that. It didn't take years because of the nature of the event. Journals like Science and Nature were publishing articles on a very expedited basis. But for journal publications, what's something else that happens with papers submitted to journals that are accepted for publication but not yet published? Peer review. after the peer review and all of that, and we got the final paper, but it's not coming out for 3 or 4 weeks. Pre-publication copies, but okay, so I won't torture you. Embargoes. Embargoes. So what if you're somebody like me who's working on this problem and has some conflicting information, like the question about whether or not the oxygen sensor that we're using is contaminated by oil gives false readings. You'd want to know that, right? You want to know that because you want to know whether or not that oxygen depression was real or was an artifact of the instrument. And it turns out that some researchers had information about that. And in addition to, let me step back up. The reason that it even came to question was the manufacturer of the instrument said, there is some evidence of this. We don't think it's affecting it. Well, there's pretty high level of interest in this oil spill, and if you get the answer wrong, some people might not be happy with it. So you want to make sure that answer is really right. So can you get access to data from another researcher who's publishing their results that's at the point that it's embargoed? Well, that's a concern. Researchers, publication, it's important, right? It's the culture of science, at least in this context. So part of what happened was, and this was in the journal Science, was this issue got raised up to the editors of Science, who in turn reminded their researchers that the embargo did not apply in the context of providing information to decision makers in this kind of context. And actually, if you dig into Science and you look in the information for authors and you get to the part that talks about embargoes, it will actually talk about that. So there's another piece of the puzzle in terms of information flow in this whole context of disasters and how do you access information. And one of the researchers that did work at this bill and got involved in this issue about communicating their science, and wrote an article in the Columbia Journalism Review. And this is his quote. This is a very difficult thing to do. And it's very difficult to do in this context. So where do people get their news now? Do they read the New York Times? What do they read? Facebook. Twitter, and their brethren. So I want to talk about trust and scientists. And the first factoid here, I think, is very important in the public policy context, is people trust scientists. And in fact, not just scientists, but they trust people like museums. They trust people like librarians. Also, they have a high degree of trust in them. The internet's the primary source of information for Americans about science and technology. The primary source. So newspapers are still a big part of that, but 30% from Facebook and 8% from Twitter, and these data are old now, and I bet you those numbers are higher. But we have the flip side of this. 15% of people don't have access to the internet. This and other factors that I talked to you about so far led to this research project that I'm going to talk about. So this is from treehubbard.com. It's a combination of a NASA image of the oil spill, which I think you can make out there, and a little social commentary. And this is not unusual, so this is a simple humorous source, but this very activity went on extensively during the Deepwater Horizon spill, and that is people searching out what I would call authoritative sources and trying to interpret it in the context of their concerns. So you had people digging into scientific literature who that's not their normal area of endeavor. And I'm sure you've read research papers. nodded off at times reading them. They're difficult, if you're not in that discipline, they're often difficult to interpret. But the public was trying to do this. They were trying to do it in the context of social media. So in other words, I might find an article that talked about deep subsurface oil, and I might tweet something about that with a link to the article and some commentary on what that article was saying. So that led to this, this research project, was to try and, it had multiple parts, was trying to understand how people viewed the marine environment and the ability to respond to spills, how people talked about it in Twitter in particular, and where are the information gaps and how can you improve ways to communicate. I'd be happy to make these slides available too. I don't know if you're distributing the slides from the presentation. So we're going to start off with a little bit of a complicated diagram. There's not going to be a test at the end, so you don't have to worry about that too much. But this is an approach called mental models. It's something that's research that's done by Dr. Van Bostrom, who's in the Evans School here. Thinks about this in the context of public policy. And I just put this up to illustrate that response to oil spills is complicated. And I would also say confusing. And that makes it difficult to communicate sometimes why actions are being taken in the context of the response. So this is just a little box model that talks about the relationship between what's happening in the physical environment, what you can do, and what the impacts are from that. And taking that, Dr. Bostrom conducted a series of surveys that were administered through Google Analytics. So this was done by presenting questions to people as they were searching for stuff in Google. And they knew they were being asked the questions. This wasn't a Facebook research project. And it enabled getting very large numbers of responses, over 10,000 for some of these questions, which is, if you're doing survey research, those are huge numbers. And it was able to do it relatively inexpensively. And I'm not going to go through all the data. I just want to point out, gray in the middle is don't know. And for a lot of the questions, so here's scientists agree on the effectiveness of chemical dispersants. Laboratory studies can predict effects. If you ask technical experts in this area, you would not get a lot of no's or maybe false kinds of answers. You would get more certain answers because they know the area, they know the research. The public in general, though, has a lot of gaps about this because how often, what's the last oil spill that anyone read about? The Exxon Valdez, which happened to be 25 years ago, right? But there are oil spills going on every day. It's not in the public consciousness. It may be once a year that an oil spill raises to that level. So people don't invest a lot of time in learning about it unless they affect them, right? So that's not an unreasonable behavior. So this is perceptions about the ocean. So we've got oil spills, right? What's perceptions about the ocean and how they might be affected by spills? And I know you probably can't really see what was presented to the users very much, but over half of the responders believe that the ocean was very susceptible to impacts from oil spills. And that's important to know because that presents a point of view that people are going to have about the situation as it's evolving. And then I think this is the other really important component of this problem. If you read the question, do you think an oil spill in your area is going to affect your household's economic well-being? So this is to the individual level. And 43% of people said major effects. And 28% said minor effects at least. So a majority of the people, when they asked this question, said, if there's an oil spill, it's affecting me directly. And this is just economics. The other really big issue in the Deepwater Horizon spill for many people in the area was their health. And that was the controversy over the use of chemical dispersants. So if we begin to understand these perceptions and attitudes, we begin to understand how to better communicate with people on these issues during spills. So the second piece of the puzzle, and the lead author for this was Kate Starberg, who's at the UW Human-Centered Design and Engineering, which is actually a pretty cool group here at UW. You apparently know those folks.
We asked Kate to speak and she was unavailable, but if
Oh, that's too bad. Oh, she's great.
Yeah.
She's a great speaker. So what she did was to look at Twitter. And Twitter was, this is 2010, so Twitter was just starting to move up that curve of people's use at that time. And it's really exploded, especially during disasters. People rely on Twitter tremendously. And I can tell you this from personal experience. There was a severe storm on the East Coast. It was a Dreco. Does anybody remember the? Derecho. Thank you. My Italian's not so good either. But it happens my daughter lives in that area, and her building was without power. She went and stayed with some friends. The question was, does the building have power? My wife found the answer to that question by using Twitter to talk to somebody in the area. And that's just a tiny little example. So Dr. Starberg looked at Twitter, in particular in the context of chemical dispersants. They looked at what people were talking about, who they were talking to, where they were getting information. There was a really high number of links within tweets during this oil spill related to dispersants, which is very unusual. And they tracked down what those sources of information, what were people linking to in those tweets too. And then I'm just going to show one piece of this, was they looked at who was talking to who. So who were the hubs of communication during this event? And you probably can't make this out very well from the back of the room, but it's a pretty cool graphic, I think. These are all the connections. These are all the people who were talking to each other, I think in those 11,000 samples. A big part of it was the official site, that's sort of the purple dot here in the middle. Right there, but this is the National Wildlife Federation, an NGO. International Bird Rescue Organization is a group that deals very heavily with wildlife during spills, and several other groups. And then off to your right, do you see the red part? So the red part was basically conservative political organization that was trying to leverage the spill to, because remember this is before the last elections, right? Before the re-election campaign, trying to use this as a lever, similar to what Katrina was to Bush, to make the president look bad. And they would lob stuff into the conversation to see if it got picked up in social media and retransmitted. So this really complicates the situation in a very large scale. So here, some of her takeaways. And the next to last bullet is one that really hits home for me, and that relates to a theme I've talked about a little bit, is uncertainty, scientific complexity, and trust. So we have uncertainty and a complex situation from a scientific perspective. Who do people trust for their information, and why do they trust them? And how do you help them work through the complexity and uncertainty? Because uncertainty is often interpreted as disagreement. And you all know, hopefully you know, that their disagreement is a healthy and expected part of scientific discovery, right? You have different viewpoints, and they're debated, and they're researched, and some bubble to the top. The Earth is not flat, for example. It was not well, actually, it was a pretty widely held belief in ancient times, as it turns out. But let's take climate change, for example, and whether or not there's a human cause of climate change. It turns out about 97% of scientists, based on peer-reviewed publications, believe that that's true. So that's a preponderance of the evidence. There is still uncertainty associated with that, and you understand, I'm sure, as well-read individuals, how that uncertainty is being leveraged in a public policy perspective. Same thing happens during oil spills. So how do we start to solve some of these problems? Well, one of the ways we do it is to be better prepared for spills when they happen. And the way you do that, one way that you do that, is you play through scenarios, what might occur. And you can think about this, there's a little diagram up there, in a qualitative way or a quantitative way. And as you get more qualitative, you get into the realm of stories. You tell stories about what might happen. It turns out stories are very good ways to communicate with the public about particular situations. Models are really ways that scientists like to communicate information. And they're kind of at different ends of the spectrum. But scenarios get at this question is, what are the possible futures? What's probable? So there are some possible futures that are not very likely. And then what would we like the future to look like? Well, the answer to the third question is one that's very interesting in this context because it depends on who you are. If you're, for example, someone who wants to drill for oil in the Arctic, your preferred future are scenarios that you could manage very well. If you're someone who's opposed to drilling for oil in the Arctic, you might look at scenarios that perhaps are less likely, but are harder to deal with. And so have you explored that situation space with scenarios? And there's a way to look at that. You know, on the right side is sort of, you fill out the forms, you describe the situation. On the left side, you look at a situation. The dark area, in this case, is the water. The light area is the land. You have an oil spill, and it might go three places. One is a wildlife preserve, one is a tourist hotel, and one is a nuclear power plant. Which is the worst case scenario? If you're the nuclear power plant operator, which is the worst case scenario? If you run the wildlife preserve, which is the worst case scenario? So we have this mechanism in place, this regulatory mechanism that requires that we do scenario planning for worst case scenarios. And they're defined in one particular way. And depending on who you are, the worst case scenario varies. So you can look at it. You can look at it this way. So when you develop the scenario, you develop a contingency plan on what you're going to do if that scenario happens. And those of us who live in Seattle, or those who are in Florida and other places that are subject to natural disasters, are encouraged to have their own contingency plan for if there's a natural disaster. If you live in Seattle, what are you supposed to have in your house? 2 days worth of water, some snacks, etc. If you're in Florida, you need to know where your evacuation route is, if there's a hurricane, those kinds of things. That's your contingency plan. Well, we have the same thing for oil spills. So I mentioned we have plausible situation space, something that might happen. We have probable situation space, something that, based on some criteria, is more likely to happen. And then we have the preferred situation space, which is where the contingency plan is constructed. And oftentimes that involves something that we think about as risk attenuation, which is contracting the risk to a scenario that seems to be favorable. That's not a good situation. If you expand the number of people who are engaged in these kinds of operations, then you can expand the areas that you might consider in that situation space. But you still have this balance because there are members of the public that might want to amplify risk because, for example, they want a city president not to get elected the next time, or for some other reason. So we have this tension between amplification and attenuation, and you can use scenarios as a way to bring people together to talk about and address those and develop a situation space that is appropriate for the situation. In other words, balances the attenuation and amplification problems. So the last piece here I want to talk about is based on the research that we did. So what? What do you do? And what we did was to develop a set of cases, of example cases of things that can be done during spills, or during preparedness and during spills, to help improve communication of scientific information so that people could both judge what was being done by the response and also judge the issues that they had personally, whether they're health, economic, or other issues that might affect their own life. And we looked at this in three contexts. One is sort of the traditional way communication is done, which is outreach, and that's one-way communication. That's what I'm doing right now, for the most part, right? I'm speaking to you. It's a one-way street. It's usually from the authorities to the public, and that has a valuable role, particularly related to facts. What's going on? Why is, where are you going next? What actions are going to be taken? Consultation is a second piece. That's a structured dialogue in some way where you're engaging people in a dialogue. You're not sharing decision making in that case, but you're gaining understanding if you're the decision maker. And the last piece is participation, where there's some kind of joint problem solving or collaborative action. And again, that might not necessarily be require ceding some decision making authority. You still have collaborative action and joint problem solving without doing that. And so that came up with these example practices. And part of that came from, I mentioned the research, the survey work using Google, for example. That's work that could be done during an event to get an understanding of the areas that people are most concerned about, where their sources of information are, who they're trusting, who they're not trusting. And then you can improve your communications, for example, if you're doing outreach, or if you want to engage in other activities. Another one is more effective use of Twitter, both in terms of communicating with people, engaging with people, and listening to people. And it's an important listening tool. And there's also using digital volunteers, citizen science. Have any of you been engaged in citizen science activities? A few. This is an area that's kind of ripe for citizen science, citizen participation in terms of collecting information, and some ways to do that. So you can see examples there. So that's the end of what I'll talk about in terms of the research project. Any questions about that?
You mentioned the embargo, and that's obviously a publisher's restriction on when they're going to release the information, but it's also the author's responsibility to where they're publishing, so there's big push for open access.
Yes.
It's federally funded, so, you know, and then there's the, I need tenure, I need to have 5 more articles on my thing. So, you know, we can go back and say it's the embargo of the publisher, but my question is, what is the responsibility of the scientist or the researcher to know the restrictions of the data that they're providing and to weigh it against that golden tenure or the pat on the back from their department?
Well, I think you've made a good point. There is a joint responsibility here. And I think it does depend in part about who's funding the work. The context, there is also, I believe, an obligation of their institution and how they handle that. Because institutions are not beyond promoting the work of their researchers in order to gain greater visibility, right? So it's not, science is not altruistic. So you have to understand all those tensions that are in play. And I think you raised good points. Okay, I started 5 minutes late, so I have 5 minutes after. I want to just talk a little bit about instruction. So I mentioned I teach this class. This is the class this year. It's the final day of the class. And the final day of the class, they run an oil spill exercise. And the requirement of the class then is to take a group of students who are mostly taking a class to meet a science requirement. If they were science majors, they probably wouldn't need to take my class because they would already have met their science requirements, right? The natural world requirements. So it's mostly people in majors other than science. I would say it's 25 students this year. About 5 were science majors. So they have to go from knowing as much as you, for the most part, probably know about oil spills, which is a general knowledge from public sources, to being able to run an event and make decisions, make recommendations. And that's what we try and do. So this is the class, interdisciplinary exploration of marine oil spills. This is also a question on the quiz that typically only one person ever gets right, which is what's the name of the class? And the name of the class is on every slide, is on the first slide of every lecture that I do. That person gets a candy bar. But really the class is about environmental literacy. And it's about the ability to understand scientific information that's being presented in a whole range of social problems. And climate change is the easy one to talk about, but there's a whole bunch of other ones, to health effects, to pick up the newspaper, and you will see several science-based issues that are public policy issues. So how, as a sort of consumer of information, I don't kid myself to think that I'm turning anybody into an oil spill responder in the class. I'm hoping that what the goal of that class is for the individuals is they will be intelligent consumers of scientific information in the context of the society in which they live, to get very idealistic. And we talked about this a little bit, about environmental literacy and what does that mean. This is the way that course is structured. But the thing I want to mention is one of the things I try and do in the class is to get them reading. I wouldn't say I try to do it, it's a science, so they have to do it. Primary literature in the field. And this is something that undergraduate students are not necessarily doing in anywhere outside their major. So if their major is outside of science, they're certainly not reading scientific literature. And journal articles for many disciplines are not the means in which you convey the state of knowledge and practice in your discipline. It may be books, it may be sculpture. And there's a final paper in lieu of an exam because I hated final exams. And I'm finally in a place where I have some control. So in thinking about this, there are some very technical scientific concepts that the students need to understand. And this is an example of trying to understand oil effects on marine life. In order to do that, you have to understand exposure. You have to understand routes of exposure. You have to understand what happens when the exposure takes place within the organism. Like for example, if you're a vertebrate and you ingest oil, your physiological system is really good at metabolizing the oil to non-toxic components. So for example, if you're a fish, you're not going to wind up with oil in the flesh of the fish for the most part that was ingested, because it gets metabolized. Now it might wind up in the liver, it might kill the fish, but it's pretty difficult to get high levels in the flesh. But it's, you can get it by coating the fish as you catch it. That's probably the primary route for human exposure. But this becomes a tremendous human health and economic issue from oil spill. So you have to understand all these pieces in order to understand whether or not, if I ask a question about whether or not we should close fishing in an area of an oil spill, you have to have this background in order to answer the question. So we try and get to that level, and this is one of the ways I try and get to see whether or not they get the concept. I ask them to write a sentence that addresses the life history stage, the route of exposure, whether or not it affects an individual organism, a population, or an ecosystem, and whether or not the effect is acute or chronic. So acute is, I die right now, chronic is, maybe I die later. And you have to understand all those concepts, and lethal and sublethal. So do I die or am I just impaired? You have to understand all those concepts. And sometimes it helps to express those concepts in a way that students can relate to. So this is a sentence. This was my sentence. So you can actually see that in this case, it was a sublethal dose of the toxicant that led to death of the organism, which happens. So if I'm a bird and I get my feathers oiled, I might not die from a toxicity associated with the oil, but I might die of hypothermia because I lose my insulating capability. In this case, the alcohol affects the judgment of the individual and results in a lethal event. Now that can also happen in nature, because let's just take a bird for example. If I have a sublethal dose and it changes my behavior and now I'm more easily predated upon, I'm also dead. So these are complicated issues. And this is one way to begin to get out of it. Even toxicity and alcohol is great discussion in class. And so this is an example of using literature, primary literature in the field for an assignment. So this is a particular paper about how do you build performance metrics? How do you know whether or not your response to a spill is a good response or a bad response? And I had to explain topological here. So this is the assignment. A little bit about the paper, what are ideal metrics? And then this is what they have to do. They have to try and understand if they understand the article. So what are the key arguments? And these students are pretty good at this. But then the third bullet is the one that challenges them. And I mentioned most of these students are not science majors. Is propose your own example performance measure in the context of your discipline. So if you're a business major, you might, that's kind of easy, but what if you're studying classics? What if you're studying French? The students that have the hardest time with this are the science majors. And then, explain, you don't get just to do that, you got to justify the answer that you gave. And so I would say, as an instructor, so I'll tell one anecdote. I have 3 minutes left. I'll tell one anecdote. Is the first time I taught this class, it was one of the first classes that I taught. And I got back my course evaluation forms. For people here at UW, you know what the system is. The students fill out forms, little bubble things, how, what was the course like, etc. And then they get these yellow sheets where they get the right comments. And so I'm reading through the yellow sheets, and sometimes they're really good. They answer some standard questions. And I'm reading one, it's about the 5th one in, and it says, best class I've taken at UW. And then I turn the page. Worst class I've ever taken. But every once in a while you get to feel like you're accomplishing something. And this is an example that just blew me away this year of the final paper. And the requirement of the final paper was you had to write a paper that was based on the course context. Now, you could write it from a number of different perspectives. And this is the paper that this particular student wrote, Truth to Power Beyond Rhetorical Analysis of Genre and Ethos following the 2010 Deepwater Horizon oil spill. That was bringing all the pieces together. And what she did is she started with an authoritative source. It was a paper, it was a spectrum of truth to power. And I would say one of the challenges that I face as an instructor, that librarians, and I point them to the library when I assign this paper, is for students to understand what primary sources of information are, what do they do? And so this is a case where a student took that, took a primary, not just one primary source, and then brought in Aristotle and wrote this paper, which was a great paper. So starting with a disaster, I hope the story made sense as we work through to how does that get to the classroom and instruction, and how do you use that information to improve the learning experience for students. Thank you. And happy to Yes.
I could probably look this up myself, but I was curious whether there has been any detailed analysis done in comparing Deepwater Horizon and Exxon Valdez oil spill as far as sort of the larger public perceptions about the events.
Not in a sort of overarching way that I'm aware of. I think there are some papers that look at particular areas, and community impacts on communities is one area. There's a lot of work coming out of Deepwater Horizon. There's a little bit after the Exxon Valdez, particularly the neighboring communities. But they're more sort of topic specific.
Yeah, because I think that would be an interesting point to look at, just simply because 25 years, well, not quite. It's been 4 years since Deepwater, say 20 years between Exxon Valdez and Deepwater Horizon. There was no Twitter. There was no, I mean, the ways that the public actually got information about Exxon Valdez was far different than what it was for Deepwater Horizon.
Absolutely.
So it seems like that would be a very interesting point to look at.
I would agree with you. I don't know, maybe somebody has done it, I'm not aware of it.
Yeah, I haven't seen anything, but I'd be kind of curious to look and see if
Yes?
I just have a question. Was there a reason the oil was attracted to that particular layer because of the oxygen-rich environment? Is there a reason?
There wasn't a chemical reason, it was really just sort of the physics of the oil droplet size and the density of that water. And the fact, the way that the oil was coming out of the well. So the oil came out under pressure. So part of it was it basically got ejected into that layer. So there was, they ran out of steam. Those droplets ran out of steam about when they hit that next oil.
I remember back when I was in college back in California, and we had the Santa Barbara oil spill. I remember distinctly that. At the time, it was very easy to just dump on the oil companies until you start reading more about the ecology of the whole area, that there's a lot of just natural oil coming out by itself in that area by drilling.
Yeah.
And from then on, I started to just kind of step back and away from all the rhetoric, kind of disperse and collect my own facts, because it's easier that way. It's easier to jump on one way or another without all the facts.
Yeah.
It's part of human nature.
And it's true in the Gulf of Mexico too. There's a tremendous number of natural oil seeps. There are natural oil seeps just right in the area of the oil well. But it presents, from an ecological perspective, it's a different, the organisms see a different world when they have a little bit of oil every day versus when they have a lot of oil all at once. But you raise an important point, is that it is easy to point a finger and blame. And it's easy to point a finger at BP, although somebody mentioned Halliburton at the beginning. But the problems are more complex than that.
Do you think, are you optimistic about the ability, given the social and political context that we currently exist in? I just finished reading a book about Rachel Carson. So that was a quieter, gentler time, but there was legislative action that was effective in limiting the use of DDT and sort of solving that problem. And she raised that problem in the way that she had to raise it. And now we have the Keystone Pipeline, for example, and the rhetoric is as heated as he's describing rhetoric being heated, and we have a different society. I don't know. Are you optimistic?
Oh, I'm a parent, so I have to be optimistic. But I think in terms of moving forward on sensible environmental legislation, I don't have a whole lot of hope there in what I can see. I think Keystone Pipeline is the one that's raised to the forefront. The environmental issues right now are really associated with fracking and transportation of oil by rail. And I don't see much happening in the other issues. It's a more complicated problem. By the way, those were Kate's takeaways from that. But you have to do that, so you can't ignore tradition, what I would say people often consider traditional sources of media, so newspapers. But people in these kinds of situations really rely a lot on word of mouth and their social networks, which actually exist in the absence of things like Twitter. Sometimes we forget that, right? Those are really important. So you have to have things like public meetings. You have to find sort of influential people who can read and work with them. There's a lot to learn from the health community in these areas, because they face these problems every day in lots of different ways.
I have a question about your students' bibliographies.
Yeah.
Just out of curiosity, how well, they're doing interdisciplinary studies here. How balanced is their ability to use the research tools, let's say in communications, media studies here? Are those showing up in the bibliography as well as the science requirements that you have? Or is it more pulling from an area that they've learned, let's say the science, and applying it to some newspaper articles, some knowledge, previous knowledge of Aristotle? Or is there an ability that they've developed to deal with media studies research, deal with science research? So I guess I'm asking, to do interdisciplinary work, you have to develop competencies in all of these different areas of research, and it's a different language, different techniques. How have they done with that?
I would say it's a very wide availability among the students. One of the things about this class is I have freshmen through seniors. So there's a difference in that respect. And I think there's just an individual difference. I would say that I read 25 papers. I would say that 3 students, and these are our students, really did what you, were capable of what you just talked about, being able to extract from multiple disciplines. And I would say it's sort of, there is a spectrum down from there. I would say nobody failed, what I would consider failed at it, so everybody had some capability of it. But I would say that's an important challenge for students here. You want to take this away?
Yeah, I think we can. Just a few seconds of housekeeping. It is lunchtime now. Sandy Doughton is back, and she has brought more books. So if you didn't get a chance to buy a book last night, you can do that right now out here in the Commons. Lunch is back over at Lander, and then we all meet back here at 1:30, and we will divide into our groups for the workshops in this room. So please be back here at 1:30. Thank you. Oh, and one more.